Hello, today we're going to learn how to do logistic regression on SAS. So I'm going to open up my SAS and my logistic regression codes here. So I'm going to do a very simple case which looks at the number of hours that you have studied and whether you have passed the test or not. So I have my data step. I have an ID which indicates the ID of the student, and I have whether you have passed or not. And obviously logistic regression, your dependent variable has to be dichotomous. It's 1 or 0. In this case, if you have passed, it is a 1. If you have not passed, then it is 0. And I have hours, which means that the number of hours that you have studied. Okay, so I'm going to read in the data step first, and I'm going to run it, and it probably has run correctly. And I'm going to run my logistic regression. It's very simple. It's proc logistic, and I'm going to have my data. And I do have to set as descending. So by default, actually what proc logistic does is that the dependent variable, in this case, it's going to be 0 or 1, but in my case, pass is a 1 and a fail is a 0. But if I don't use descending, it kind of assumes the other way around. So which means that pass is 0 and fail is 1. So I have to have it as descending. And this is my model. Obviously, my dependent variable is pass, and my independent variable is number of hours that you have studied. So let's run this and see what we get. Okay, my logistic is running, and it seems that this is the result that I get. Okay, where do we look at this? The key point that we're going to look at is our estimate, parameter estimate, which is hours, so that we see here. Okay, it gives me a estimate of 0.4949, standard error of 0.3841, and it gives me an odds ratio of 1.64, and this is my 95% confidence interval. So it seems that my odds ratio point estimate is 1.64, and how do I get this? If I take the exponent of 0.4949, then I would get my point estimate of 1.64, which means that the odds ratio is 1.6 more, meaning that my odds ratio of passing over failing is going to be increased by 1.6 more if I study one more additional hours. Okay, so seems like a good estimate. So obviously, if I study more, then I probably would have a higher likelihood of passing the test. But however, is it significant or not? It doesn't look significant because it seems that my 95% confidence interval includes 1. So it's not significant. And I can also check my p-value is not significant at our normal significance level, which is 95% significance level. Okay. So that was the very simple example. Let's go to a more interesting example in this case. So which is, I'm going to read in a real data here. So thanks to dmanalytics.org, they also provide a data set. So I'm going to use a data set from their textbook. Okay. And I have downloaded into this file here, c.sas. And the file is, by the way, chapter 14 relay C test. I'm just going to use the test file. So in this case, I'm going to read it in. I'm going to call it retail relay. It's a Excel format, and the sheet is contained in relay test.csv. And it does have headers, so that's why I called it as get name as yes. So I'm going to read in this Excel file. Okay, so I'm going to read this in. And it seems that I probably will have it on my work directory just to kind of check that where it is. Let's see where I have it on my work directory. So here it is. So this seems to be the file that I have downloaded. Okay, so it has a lot of variables, but you can probably guess that the one that we will be using as a dependent variable would be retained, because we want to see that whether the customer has been retained or not. And it seems that there are several independent variables that we can include in order to estimate our logistic regression. Okay. So now, having that in mind, let's look at the first thing that we would probably want to do, which is run a logistic regression looking at retain as our dependent variable and average order, which means that the average order amount that the user has spent on a average purchase. So we want to see that whether this is a important independent variable, because it kind of makes sense. It seems that somebody is making a high order amount in terms of dollars. Maybe that's a good indication of this person being retained as a customer. Okay, so what I'm going to do is I'm going to run the logistic regression here. Okay, and this seems to be the result. I get a point estimate of 0.000467, and I get a odds ratio estimate of 1. Okay, so it doesn't really seem that this has been a important way to estimate our dependent variable, because it seems that the odd ratio, which is in this case the probability of being a customer over probability of not being a customer, is increasing by nothing, meaning that if I use one additional dollar in terms of my purchase product, the probability of being a customer over probability of being not a customer is equal. So it's meaningless to use my dollar estimate as a way to see that whether this person is retained as a customer or not. Okay, so that seems a little bit interesting result, but let us try use a different type of independent variable. And let's say in this case, I'm going to use doorstep here. So let's run doorstep. So meaning that doorstep is whether this customer ordered a doorstep service for their delivery. Okay. So obviously, if you think that somebody is ordering doorstep, meaning that you're spending a lot of money because you have a lot of um, grocery that needed to be delivered to your doorstep rather than to your local pickup place. So in that case, maybe this is a good indication of being retained. So I'm going to run my logistic regression and see what happens. Okay. And now it seems that I get an estimate of 1.0099, and that's a point estimate of 2.745. Okay, and it seems quite high, meaning that if I order a doorstep, it seems that being able to retain that customer is increased by 1.745. So that's a quite nice increase. And is it significant or not? And it seems that it is significant, because that the confidence interval does not contain 1, and my lower confidence interval is actually over 1. So that's significant. And also you can cross-check that with my significance level here. The p-value seems like it's below 0.001, so it's very much significant. So it seems that if somebody is ordering a doorstep delivery to their house, it seems that that person is very likely to be retained as a customer. Okay, so that was the logistic regression part here. Now let's try to do a multinomial logistic regression. So meaning that, okay, in some of the cases, maybe your dependent variable isn't dichotomous. Maybe you want to have a polychotomous dependent variable, meaning that you have more than 2 dependent variables. So, I mean, more than 2 outcomes in the dependent variable. So what I did was that I used the original data set retail relay here, and I divided up the dependent variable into 3 outputs. So I'm looking at a person who has an average order of less than $100. I'm going to call that person group 1. And for somebody who has over 100 but less than 200, then I'm going to call that person group 2. And obviously, if somebody has an order amount of more than $200, then that person is going to be group 3. So maybe in some cases you want to have a different segmentation in terms of looking at your customers. So you want to divide how much average order that have they place. So let's see if that is a good way of trying to understand our logistic regression in a multinomial way. Okay, so I'm going to create my data set here. Okay, so I've created my data set, and let's try to run a multinomial logistic regression. Okay, how to run a multinomial logistic regression is pretty much the same. You can use proc logistic here. And my dependent variable is, again, it's my group. It's the new variable that I just have created, which has 3 outcomes, 1, 2, and 3. And I'm going to use doorstep again as my independent variable. So I want to see if somebody is more likely to use a doorstep, maybe in some way that could be predicted in the group. Okay. And in order to use a multinomial logistic regression, I have to create a link. So I have to call glink here, my link as glink, which is general logit. Okay. So what I'm going to do is I'm going to run this. I forgot to put my quit there just to make my SAS program happy. So I'm going to run and let's see what happens. Okay, it seems as though this is the result that I get. Okay, and probably you notice that if I look at the outputs here, so these part are the outputs that I need to look, the maximum likelihood estimates, and I probably need to look at the odds ratio here. And all of the cases, even though that the group has 3 outcomes, it seems that SAS is using group 3 as my reference. So if I want to change that, I could obviously put a descending at the end of this part, okay? But I have decided not to do that in this case. So if you use descending here, you'll probably get a reversed outcome, meaning that 1 would be your reference, okay? So let's leave it now for this. Okay, I'm going to look at my outcome. So it seems that doorstep is giving out estimates for what they look like. Compare it to its reference to the third group. Okay, so doorstep 1 means that in reference to the third group, my point estimate is negative 1.3588. Or if I look at my odds ratio, it's 0.257. Okay, meaning that if I'm in group 1, I am this much likely, okay, 0.257 likely to order a doorstep service if I'm in group 1 compared to group 3. Okay, so this is a value that is less than 1, meaning that it is very unlikely that group 1 is going to order a doorstep service compared to group 3, which kind of makes sense because group 1 are the people who orders less than $100. Group 3 is people who have ordered more than $200, meaning that if you're ordering more than $200, you probably have a lot of amount and it could be quite heavy, so maybe you would prefer a doorstep delivery. Okay, now going to doorstep 2, so now the point estimate is 0.37, which means that it is 0.37, group 2 is 0.37 likely to order compared to its reference group, group 3. Okay. Now again, remember this is a value that is less than 1, which means that it is group 2 is less likely to order a doorstep delivery compared to group 3. Okay. So, which also makes sense because these people are people who are ordering between $1 and $200, and that is still less than the $200 that the group 3 is ordering. So that's why they probably would think that they don't want to use the doorstep delivery. And for both of the cases, it seems that the point estimate is quite low. And if you look at the confidence intervals, it doesn't contain 1. So yes, it is quite significant that they are more unlikely to order the doorstep delivery, and that is also confirmed by looking at the p-values here. Okay. You can also run the multinomial logistic regression using catmod. It's a little bit more complicated here because you have to add in a couple of more lines. So rather than using no lines for the logistic, for catmod, you have to direct your doorstep as your independent variable. You want to say your responses will be related to logits, and your model will be group, which is your dependent, and doorstep as your independent. And if I run this, then I would probably get identical results. And yes, you probably noticed that I do get identical results as the first case. So yes, that's how you would do the logistic regression or the multinomial logistic regression for this case. Okay, so today we kind of reviewed logistic regression and multinomial logistic regression, and I hope this video was helpful. Thank you.